Billions of years ago, Mars was a radically different planet, a world with vibrant blue skies, flowing rivers, and expansive oceans. This is the Mars scientists believe existed long before it transformed into the parched, barren landscape we see today. Today, we're diving deep into the interesting transformation of Mars and exploring the processes that reshaped the red planet from a potential cradle for life into the cold desert we observe now. Recent evidence gathered from NASA's rovers and orbiters indicates that Mars once had liquid water on its surface. Features like river valleys, ancient lake beds, and minerals that typically form in water suggest a wetter Mars. The most significant channels, such as Valles Marineris, stretch for thousands of kilometers and plunge up to 10 kilometers deep, dwarfing the Grand Canyon here on Earth. Imagine those majestic Martian rivers winding their way through vibrant landscapes. Scientists estimate that ancient Mars may have boasted oceans covering about 19% of its surface, an area roughly equivalent to the Atlantic Ocean. The northern lowlands of Mars are particularly intriguing. They appear to be remnants of an ancient ocean bed that might have held more water than the Arctic Ocean. Picture the Martian landscape dotted with lakes, rivers carving through valleys, and the possibility of rainfall nourishing these waterways. This vision is backed by discoveries of hydrated minerals and sedimentary structures formed only in the presence of water. These ancient lakes could have been havens for life, much like Earth's primordial soup, where life began to flourish. So, how did Mars transition from this potentially habitable world to the arid wasteland we see in rover images? To grasp this transformation, we must examine the planet's magnetic field and atmosphere. A planet's magnetosphere plays a crucial role in maintaining its atmosphere. Earth's strong magnetic field shields us from harmful solar radiation and helps hold our atmosphere in place. Mars, too, once had a magnetic shield. This magnetic field is generated by the movement of molten metal in a planet's core. Earth utilizes the geodynamo effect, where the motion of liquid iron and nickel creates a magnetic field extending far into space. Mars, being smaller, had a similar but weaker magnetic field that protected its atmosphere from the relentless stream of charged particles known as solar wind emitted by the Sun. However, over time, Mars lost this vital magnetic field. This loss likely occurred as Mars's inner core cooled down. Because Mars is smaller than Earth, it cooled more rapidly. When its core solidified, the planet could no longer generate a magnetic field. Studies indicate that Mars' magnetic field vanished approximately 4.2 billion years ago, rendering the planet defenseless against solar wind. Without a magnetosphere, Mars became vulnerable to relentless solar wind. These charged particles bombarded the planet, gradually stripping away its atmosphere through a process known as atmospheric sputtering. This took millions of years, but the consequences were catastrophic. The once thick atmosphere of Mars dwindled to a thin shell that is less than 1% the density of Earth's atmosphere today. As Mars lost its atmosphere, it could no longer retain heat. Consequently, the planet cooled down, and any remaining water either froze or sublimated, turning directly from ice to vapor and escaping into space. Mars transitioned from a warm, wet environment to the cold, dry planet we see today. The average surface temperature now hovers around -80 degrees Fahrenheit, far too chilly for liquid water to remain on the surface for any length of time. Could Mars have supported life? Scientists think it's plausible. The presence of liquid water is a critical ingredient for life as we understand it. If Mars had enough water for an extended period, it's conceivable that microbial life could have emerged. Early Mars shared conditions similar to those on early Earth, where life first took root. Both planets experienced volcanic activity, maintained a thick atmosphere, and had liquid water, all vital ingredients for life. If life did exist on Mars, it would likely have been simple, single-celled organisms. These microorganisms could have thrived in nutrient-rich waters, possibly around hydrothermal vents, akin to early life on Earth. Hydrothermal vents provide heat and minerals that can sustain life, making them prime candidates for the origins of life on both planets. So, why is researching Mars' watery history so crucial? For several reasons. First, it enhances our understanding of the solar system's history and the conditions that foster habitability. Additionally, it lays the groundwork for the search for life beyond our planet. If life could independently arise on Mars, it suggests that life might be more prevalent in the universe, possibly existing on many other planets. It's important to note that Mars and Earth share several similarities. Both planets have polar ice caps, resemble each other in landforms, and possess a history of volcanic activity. By studying Mars, we can glean insights into our own planet's history and evolutionary processes. For instance, the volcanic regions of Mars, such as Olympus Mons, the largest volcano in the solar system, could provide insights into volcanic processes that may have also occurred on early Earth. The knowledge gained from studying Mars is crucial for future human exploration. Scientists and engineers are actively developing plans to send humans to Mars. Understanding the planet's history and resources is vital for these missions. Future explorers could utilize local resources, such as extracting water from ice or leveraging Martian soil for agriculture, to support long-term endeavors. It's not far-fetched to envision a future where humans live and work on Mars. We could harness the planet's resources, like water ice, to sustain life and establish a permanent presence. This dream is inching closer to reality as technology continues to advance. Concepts for habitats, life support systems, and transportation are being developed to facilitate human life on Mars. The search for life on Mars is far from complete. Upcoming missions from various international space agencies and private companies aim to delve deeper into the Martian surface and explore new regions. The European Space Agency's long-awaited ExoMars rover is scheduled to launch in 2028, with plans to drill into the Martian subsurface to search for life, where microorganisms could be safeguarded from harsh surface conditions. Technological advancements are pivotal for these explorations. Innovations in robotics, artificial intelligence, and remote sensing are revolutionizing our ability to study Mars in unprecedented detail. These technologies enable us to analyze vast amounts of data and uncover discoveries that were previously unimaginable. The journey of Mars exploration has been long and challenging. Early missions, such as NASA's Mariner and Viking programs in the 1960s and 1970s, laid the groundwork for our current understanding. The Mars rovers, Spirit, Opportunity, Curiosity, and Perseverance have built upon this legacy, each mission contributing fresh insights and discoveries. Looking forward, the future of Mars exploration is indeed bright. Collaborative efforts between space agencies, private companies, and international partners are broadening our capabilities. The Artemis program aims to return humans to the Moon, establish a foothold there, and potentially create a lunar base that could serve as a stepping stone for future Mars missions. When we consider the bigger picture, Mars is not just an endpoint. It's a gateway to further exploration. The technologies and strategies developed for Mars missions will also aid in exploring other destinations, such as the moons of Jupiter and Saturn, which may harbor subsurface oceans and potential life. As we gaze up at the night sky and see Mars shining brightly, we begin to understand that this distant world once had the conditions to support life. Our quest to uncover its secrets is just getting started. Who knows what amazing discoveries await us as we continue our exploration of the Red Planet. We hope you enjoyed this journey through the ancient history of Mars. Don't forget to click that subscribe button for more thrilling discoveries about our solar system. And if you found this video informative, give it a thumbs up. Your support helps us continue to bring you interesting content about space exploration.